Yeah, let's start.
Okay. Uh, Good morning, everyone. So today we'll be solving the DBMS part of the GATE 2024 Data Science and Artificial Intelligence paper. So there are a total of 4 questions, out of which two were 1 mark questions and two were 2 marks. So in total, it was around 6 marks. So we'll solve these 4 questions today. Okay. The first question is an MCQ question. We'll look at this. So we are given a database that has the following relations. The first one is the defender, second one is forward, and the third one is team. So the question they are asking is, which one of the following relational algebra expressions checks that every name that occurs in the team appears in either defender or forward? Okay. So you have uh, this team relation, and you want to check whether all the tuples in the team relation appear either in defender or in forward. Okay, so let's look at the options one by one. Okay, the first one is uh, this one. So in this one, we are taking the projection of the name column for the team relation minus. Okay, this is the set difference operator. Hmm. So in this one, in option A, what we are doing is we are taking the projection of the name column from team, and from that we are taking the set difference of the intersection of defender and forward. So what option A will give us is, it will give us the basically it will uh, what you can say, subtract all of those names from the team who are both defenders and forwards, right? So we don't want that. We want uh, those names from the team who appear either in defender or in forward. So this one is capturing those who are appearing both in defenders and in forward, right? So if we look at option B now, option B is saying that you're again taking the players who are both the defenders and forwards by taking the intersection, and from that you are subtracting the team, all of the players in the team. So we want to check that every name that occurs in team appears in defender or forward. So let's say that you have in your team X, Y, and Z. Okay. And you have, this one is team. And in defender, let's say you have let's say X, and in forward you have Y and Z. Okay. So if we look at option B, the intersection will give us for defender and forward, the intersection will give us phi, right? The empty set. And if you look at then we are subtracting something from phi, so we'll get the result as phi. Okay. But what we want to check is whether every name that occurs in team occurs either in this relation or in this relation. That is what we wanted to check, right? So that is captured by option C, which is saying you take the union of the defender and forward. So if we take the union of these, we'll get X, Y, and Z. And then you subtract that from team, right? So this will give us the phi set. So this is the correct option because this captures exactly the statement that they've asked us, right? And option D is wrong again because it is taking the union and it is subtracting the names of the players in the team from that. So that is the other way around, right? If you had, let's say, one more player here, A, then it would not have been an empty set, right? For option D. So option D is incorrect. Okay. So this was a very basic and easy question on set difference and projection. Right? Okay. So this next question is the numerical answer type question, and it was based on SQL. So we'll quickly look at this question. So in this one, we are given two tables. The first table is Raider, and the second one is Team. Okay. Now, the statement they've mentioned is the attribute ID in the table Team. So this references the primary key of the Raider table. Okay. So we have this reference here. Okay, fine. So we are given this information, and this is the query we are given. So select star from Raider comma team, where raider.id equal team.id and city equals Jaipur, and rate points are greater than 200. And the question they've asked is the number of rows that are returned by the query is what? So we need to find that out. Okay. So the first thing is whenever we are trying to solve any query, the first thing that we have to look at is the from clause. Okay. So we start here. Okay. So the from is from two tables, that is Raider and Team. So we have to take the cross product of these two. Okay. So we'll have something like this. ID, name, raids and rate points. And we have city ID and bid points. So we will get one relation that has these columns. Okay. When we take the cross product. Now, in the cross product, this tuple from Raider will be matched with all the tuples here. Right? Again, this one will be again matched with all the tuples and so on. So we have 1, 2, 3, 4, 5, 6 tuples in the team relation and 6 tuples in the Raider relation. So the cross product will give us a total of 36 tuples, right? Now we have those 36 tuples, out of which we'll be filtering based on the where clause. So the where clause says that raider.id equals team.id. Okay. Now let's filter out these rows. Okay. So we want to see those tuples in the cross product where this one and this one are the same. Okay. So we have for raider 1, we have this row, right? Where the team IDs match. Let me just erase this. Hmm. So we have this one. For raider 2, we have this. For raider 3, we have this. For raider 4, we have this. For raider 5, we have Hyderabad. And for raider 6, we have this. Right? So now we have these rows. Now there is one more condition in the where clause, that is city equals Jaipur. Okay. So city equals Jaipur. Okay, we'll do one thing. We'll write these rows down. We have one, name was something Arjun. Then rates were 200. Rate points were 250. City was Jaipur. ID was 1 and bid points were 250. Okay. Similarly, we have two Mukosh 190 to 19. Okay. Jaipur to 200. Then we have Sunil who has 150 rates, 200 points. Okay. Now the fourth tuple will be Reza 150, 190. Okay. And the corresponding team tuple will be Patna 4, 200. Fifth row is Pratham 175, 220. Hyderabad 5, 175. Sixth row is Gopal 193, 215. City is Jaipur 6, 200. Okay. So we will get these tuples after the first where clause. Then after the second one, we want the city to be Jaipur. So we have Jaipur, Jaipur, and Jaipur. And these three will be crossed out. Now the third condition is rate points are greater than 200. So rate points are greater than 200 for this, and for this, right? So these three rows will be returned as the output. So the answer is 3. Okay.
One question. It is arcs
So,
greater than 200. It is not 200, right? It is not
yeah.
equal to and greater than 200.
Yeah, it is greater than.
So that means only 250 means only one should be the answer, right?
No, no, this is 250, 219, and 215.
Okay, yeah, yeah.
Hmm.
Okay. Based on red point. Yeah, yeah. Three.
Yeah, based on rate points.
Okay. Yes.
You want to check whether rate points are greater than 200.
Yeah, yeah. Fine. Thank you.
Okay. So the next question was based on functional dependencies, and this one is a multiple select question. So the question is that we are given this relation, and this is the functional dependency set that we are given. And based on this, they want to find out which of the options hold true, okay, based on the functional dependency set that we are given. So to solve this type of question, what we have to do is, as we have seen in the class also, uh, we take the closure of the LHS and we see if the RHS is contained in that closure. If yes, then this is a functional dependency that can be derived, otherwise no. So if we want to look at option A, we'll take the closure of VW plus. Okay. So let's take the closure of VW plus here. So we'll have V and W in it, obviously. Okay. And V derives X, right? And WX derives Y, right? And then WX also derives Z. Okay. So this is the closure of VW. So we want to see if YZ is contained in the closure. So we can see Y and Z is contained in the closure. So this option holds true. Now we look at option B. For option B, we have to calculate the closure of WX. So let's do that. WX. So by default, we'll have W and X in the set. Now WX derives Y and Z. So we'll have that Y and Z, right? This is the set. So they have said they're asking whether WX derives YZ, and YZ is in the set, so WX can derive it. So option B is also true. Now we'll look at option C. So option C is asking us to take the closure of VW and check if U falls in it. So we have already seen the closure for VW and U is not in it, right? So option C is incorrect. Now let's look at option D. Option D is again the LHS is VW, and we have to see if Y falls in the closure of VW. So it does, right? We have seen that. We calculated the closure of VW and Y falls in it. So option D is also true. So the correct options are A, B, and D for this question. Okay, and C is incorrect. It was a multiple select question. You have to mark all the three. Okay, moving on to the next question. So this one is a question that is based on indexing, and it was an interesting question. So let's look at that. So we have a relational database, and it has the following schema. So we have one relation that is movie, one is genre, and the other one is movie genre. Okay. Now we are given this SQL query, which is select star from movie from the cross product of movie genre and movie genre, where movie dot customer rating is greater than 3.4 and genre dot name equals comedy and movie genre dot movie id equals movie dot id and movie genre dot genre id equals genre dot id. Okay. Now the question is, this SQL query can be sped up using which of the following indexing options? Okay. And we are given some options based on the indexing. So we need to analyze that. Okay. Before that, uh, we need an index where if we want to quickly find out one particular row or a set of rows from the uh, relation in a quick manner, right? So there we use indexing. Now, here in this particular query, where will the indexing come in use? It will come in use for the where clause filtering, right? We have these four conditions in the where clause, and when we want to filter the rows based on the where clause, we'll be using the indexes to get quick access into some of the rows, right? Now, what we'll do is we'll look at each of these where clause conditions one by one. Okay. So the first one is movie dot customer rating is greater than 3.4. So movie dot customer rating is greater than 3.4. Okay. So when we want to filter this is a form of a range query, right? Because we want all the rows that have value greater than 3.4. So this is a range query. We want all those rows where the customer rating is 3.4 and from that till whatever is the maximum value, right? And for range queries, we have seen in class, right? What is the best type of index for range query? For range queries, the best type of index is B or B plus tree. B plus tree mostly is the best option, right? For range queries. Because remember, in B plus trees, the leaves have this. The leaves are connected to each other, right? So that is why we can find quickly the next leaf. If we, let's say, if we are searching for 3.4, we find this node here. From here, we can easily go to all the leaves, right? And your B plus tree has all the records in a sorted manner. So this will easily be able to satisfy the range query, right? And let's say you want to create an index for something where you will be having a random access. So for random access, you can either use hashing or you can use your B plus tree again, because the B plus tree traversal is again not a very heavy computation. So we can either have hashing index or a B plus tree index. In the hashing index, we'll just have a hash function and we'll get the location of the record, right? Based on the hash function. So now what we need to do is we need to categorize our where clauses into being either a range query or a random access query. So based on that, we'll see what type of an index we can create. Okay. So for the first condition, it was movie.customer rating is greater than 3.4, so which is a range query. So for customer rating, you can use B plus tree. Right? Hashing will not work good for range queries because as we know that in a hash table, it need not be in a sorted manner. If we have 3.4 in one of the entries, the following entry need not be 3.5, or it need not be in a sorted manner. It can be 1.2 or anything, right? So hashing is not good for range queries. Now let's look at the second one. Second one is genre.name equals comedy. So now genre.name equals comedy, right? So this is a random access, right? So it is random access because we will be accessing any row that has the name as comedy. We are not looking for a range of values. We are just looking for one value. So we can use hashing here, or we can use B plus trees for random access. Since it is basically, since it is equal to, wherever we have equal to, that is a random access query. Right? And wherever we have this sort of operations, that is mostly a range query. So again, this one is an equal to, where movie genre dot movie ID will be compared to movie dot ID. This will again be a random access, right? Because whatever movie ID you see in the movie genre table, you want to search for that ID in the movie table. So these type of a query can be easily handled by both hashing or B plus tree. Right? So let me write it here itself. Here we have B plus tree. Here we have either hashing or B plus tree. Again, here we can use hashing and B plus tree. And similarly, for this fourth condition as well, we can use hashing or B plus tree. Right? So if you put, let's say, movie genre ID, you're looking for this in the genre table. So you take this genre ID, you put it in the hash function, and you'll get the location of that in the for the genre ID, right? And for the B plus tree, you can do a traversal. You can do a search. Okay. So now based on this, let's look at the options. So option one is that you can create a B plus tree index on all the attributes. So yeah, that would be fine, right? We can create a B plus tree for all the attributes. So option A is correct. Now let's look at option B. Option B says that you create a hash index on genre.name and B plus tree on remaining attributes. Now for this option to be correct, the only thing we have to look at that is in genre.name, are we doing a random access? So we are, right? Because of the equal to. We are doing a random access, so we can use the hashing index there. So this is correct. Now in option C, is it's saying that you create an hash index on movie.customer rating and B plus tree on remaining attributes. So again, we have to check whether uh, movie.customer rating is a random access, only then the hash index will be good. So movie.customer rating is a range query, right? So it cannot perform well with hashing. So that is why option C is incorrect. And similarly, option D is also incorrect because you cannot have a hash index for the range queries. So the correct options are option A and option B for this question. Okay. This was a slightly tricky question, but the answer is simple if you analyze the indexing pattern correctly. Okay. So that is all. That is all the questions in DBMS in that GATE DA 2024 paper.
Yeah, we can move to next slide and end.